Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology. And hey, we turn podcast. Everyone, welcome into the program. Don't worry, we're in good company. It seems like everyone has a new podcast. And the golden age of podcast is upon us. And ladies and gentlemen, we're happy to be here with you. And we are happy to be here with you with Ralph Bond. He is our science and tech trends correspondent. He handles everything cutting edge, bleeding edge, and ladies and gentlemen, really a good variety of everything from construction, medical, so on and so forth. We'll get into more of what he does, but safe to say, hey, it's a great high note to kind of end the week on and go into this. So with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, reviews, videos, stuff like that. And ladies and gentlemen, with that being said, let's go ahead and just bring Ralph on and we'll talk a little bit and then get into the stories. So as I said before, longtime Computer America contributor and of course our science and tech trends correspondent now. Ralph, welcome back onto the program. How you doing?
I'm doing great, and it's going to be a real fun mixed bag of stories this week. And again, as you alluded to, folks, you're going to leave the show today feeling positive and encouraged about the future of humanity thanks to science and technology. So that's part of what Ben and I do. We leave you feeling better than you might be feeling at the beginning of the show, given this week's news cycle.
Absolutely. And so with that, I think we'll kind of jump into story number one. But Ralph, I hope that you're doing well, and everyone out there is doing well as well. Of course, just to give a little shout out to spend some time in Texas recently with family and stuff like that. And good luck to everyone out there in Texas. I know tornadoes are nothing new in Tornado Alley, but still, stuff like that. We haven't really come up with a magical technology solution to tornadoes, but maybe one day, we'll figure out all of our problems with technology. But until then, we have a few solutions for you in today's stories. So, Ralph, I think story number one is a great way to, kind of uplift people, because you're going to get a lot of uplift with what you can make with this kind of thing. There you go.
Yes,
see, my pun for the morning.
There you go. And before we jump in, just to remind everybody, every one of the stories we have here, I look for stories in the community of articles about technology and science. We put together show notes. So come out to computeramerica.com, find the Ralph Bond tab at the top of the page. You're going to find the show notes and a link to the video and all that good stuff. And if you want to dive deeper into any one of these stories, you can do that so easily through the show notes. So once again, computeramerica.com, and look for the Ralph Bond tab at the top. So with that said, first story. So every once in a while, we do avionics or aviation technology news, and this one really caught my eye. A headline here: first fully 3D printed jet engine showcases designing for additive manufacturing breakthrough. Now, there's a mouthful there, but we'll get into that and explain everything. And I saw this article in Forbes, a story by Carolyn Schwar. And we got the link to the show, or pardon me, the link to the article, of course. Also, I have a link to the company that developed this, their link and their press release, if you will, on this topic. And if you have the show notes, if you're watching the video here, you can see an image of this amazing 3D printed jet engine. It's a mini jet engine cut in half to illustrate the inside. So it doesn't look like this. Normally, it's virtually cut in half so you can see the internal components. So let's jump into this. First, a little bit of background. Today, micro turbine. So we're talking about small scale jet engines. Micro turbine engines require complex assembly processes involving many expensive parts, which puts customers directly in the crosshairs these days of supply chain dependencies, limited availability of materials and so forth, and their manufacturers maintaining the right employee expertise to complete the assembly. So this is a non-trivial kind of process to make little jet engines, okay? So to overcome overcome these challenges. Recently, Boston-based software company PTC displayed a prototype, and I want to stress proof of concept, fully 3D printed in one piece. Let that sink in. Fully 3D printed in one piece microturbine jet engine at its company product launch event. It was the middle part of last month, so not that long ago. The microturbine engine weighs about 8 pounds and is 3D printed as a single component all at once, including all rotating and stationary parts. And frankly, Ben, I just can't figure out how they did this, but that's what they say they've done. It's just mind-blowing.
Yeah, the cross sections and the pictures that that of course can be in the show notes really emphasize just how I guess when people think of 3D printing, they kind of think of little figurines, the little army soldiers, and it kind of goes layer by layer up. This has holes as scaffolding and has like you said, rotating parts. I don't know how they do this either. Nuts. It's incredible.
It is. It's a triumph of 3D printing, to say the least. So a little more background. A typical microturbine jet engine contains upwards to 33 parts that are normally individually machined and then assembled. Okay, that makes sense. Although the PTC, that again is the name of the company that did this, although the PTC prototype 3D printed microturbine engine looks solid from the outside, inside are lattice structures to minimize weight and channels to enable airflow and fuel flow. And again, you just showed the cutaway view of this engine. And then here's a quote from Steve Dertian, the PTC's chief technology officer. He said, There really are no other components required for this engine to function other than the housing. Everything else, from the bearings to the seal to the cooling, is designed in. And again, I would love to see this thing in person. I would love to see it. Just believe it's even real. It blows my mind.
I would love to see a time lapse, because these things are they're not very fast, but I'm sure that even just 3D printing this thing, even if it takes a week, is still probably better and preferable to machining 33 different parts.
Yeah, but here is a real kind of reality check. A lot of excitement here, but this is kind of interesting. PTC says this additively printed engine would fire up like any other microturbine engine, although it hasn't actually been tested in this way. Now, this is as of a publication, a few weeks ago, so maybe they have by now. But again, I just want to stress this. This is a proof of concept, okay? So as a non-commercial research project, PTC does not plan to sell this particular engine, which is curious also, but there is no shortage of companies looking to make compact turbines more affordable for applications such as lighter, moderate-sized, unmanned aerial vehicles. And if you think of what's going on in the war in Ukraine right now, boy, unmanned aerial vehicles are the name of the game. So a monolithic 3D printed microturbine engine offers the potential to dramatically bring down costs, speed up production, and introduce new efficiencies not possible with traditional manufactured jet turbine engines. And here's something that I really like also with 3D printing, also called, of course, additive manufacturing. There's no tooling required for molding or machining parts. It eliminates the need to weld or join parts, which can introduce weakness. And this part, Ben, I think is really interesting. And there's also the possibility of on-demand manufacturing on site, since there's no need to ship any components from elsewhere or have skilled labor on hand to assemble those said components. Think about a war situation. Think about Ukraine. What if they could on-site manufacture the little turbine jet motors they need, engines rather, for their drones or something like that, right? So this part really blew my mind, the idea of you could do things on demand on site. And the engine took you talk about time lapse, the engine took 13 hours to print on a metal laser powder bed fusion 3D printer. That's a mouthful, from a company called EOS, and it happens to be the Model 300. I looked that up. It's kind of interesting. And it uses a metal material called Inconel, and I hope I'm saying that right, Inconel. And I thought, I got to know more about that. What's that? So Inconel is an extremely strong and heat-resistant metal that's very difficult to machine. So in traditional manufacturing, it's often only used for exhaust parts of a turbine engine. But these guys were using this material to 3D print this little engine. Now, other manufacturers, including California-based Sierra Turbines, are also in pursuit of the monolithic 3D printed economical and efficient microturbine jet engine. So I want to qualify that PTC is not the only company on earth thinking this is an interesting possibility. These guys at Sierra Turbines, and there's a link to them as well in the show notes if you want to learn more about them, are also on the same path to achieve this as well. So an interesting development in avionics or aviation technology.
Yeah, I one of my favorite, kind of guests that we had on the show a while ago that really highlighted the possibilities of this. Her name was Bathsheba, and she did she did artwork. She did 3D mathematically inspired artwork, and she uses 3D printing to kind of get it done. And Ralph, she really liked the 3D printing because she was able to print interconnected parts that are found in kind of math concepts and things like that do not naturally occur. So like normally if you put them together, you have like a weld spot. You have to put cut one, put them together, and link them together. She was able to create her art all interconnected with no cuts, no welding, no anything. So it gave it a much more finished look. And I guess this is just taking it to the nth degree because obviously the precision you need for jet engines is much more, but it's still very, very it's neat what you can do because you couldn't do this before, and I guess the tolerances for I was just looking at EOS, the people that do the 3D printing. I was looking at their YouTube channel, and which is all the videos I was kind of poking through, and one of them was for like NASA and kind of space kind of stuff where tolerances have to be very, very fine. So it's great that it's faster, cheaper, and easier, but it's also great that you're going to get even better precision than what you could get before. So it's just a win-win-win all around. So
I agree. And again, I want to stress that little factor of making it possible on demand, on site, to make a turbine, a little turbine jet engine, is profound. I mean, this kind of wildly democratizes something that before was very much limited to a few handful of companies that had that expertise. So something to think about there. It's an interesting development.
and obviously the equipment itself is still kind of prohibitive for individuals, but then again, how many individuals do you want printing jets? But for for countries, for even larger companies,
military,
and military having that capability. And Ralph, I just gotta say that being able to share the plans, you worked with Autodesk for a long time, and kind of CAD and computer aided design. Once someone put in the work, and artists of all kinds deserve kind of royalties and all that kind of thing, but still, you make it once in CAD, and then you can print it a million times. Like that's the great part. So anyone with a plan, anyone with the machine can suddenly come out with something very, very cool. That was always the dream of 3D printing, is that you put the manufacturing in everybody's hands, not just, a few. So this further highlights that. So it's great. So story, and again, the pictures are wild. You gotta go check this out. Story number 1, story number 2, and this hits close to home for you. And another story about Intel, and with as much as they've been. I've been following them. They were, of course, huge supporters of the show, a couple years ago, and they've since been trying to pivot. They were the industry leader and still are the industry leader, by miles. But they've definitely been working on research and development in the past couple of years. That's been their thing. Putting out cutting edge products. They still do that, but trying to do more research stuff has really been Intel's focus the past couple of years. And story number 2 kind of highlights that it's not just about making your computer a little bit faster. It's all parts of the technology sphere have an influence from Intel. So story number 2.
Story number 2 is fun, and again, as you alluded to, this has a very personal kind of alma mater heartstring connection for me, because I spent 14 wonderful years with Intel Corporation here in Oregon. And we could ride a bike to the location where this research is going on at the in Hillsboro, Oregon. But let's get the story. Let's get the headline here. So, potential game changer. In a Hillsboro, Oregon lab, Intel is immersing data center computers in fluids that dissipate heat more effectively than air cooling. And I got this from our local Portland, Oregon-based newspaper, the Oregonian, a story by Mike Rogoway. And we've got the link and images and all that good stuff in the show notes. Again, come out to computeramerica.com for that. And even before we jump into this, Ben, I want to stress to the audience, we're not talking about the world's first ever attempt to liquid cool computer systems. No, but it's a little twist on that story that reflects some very good research that Intel's doing that's trying to make this more practical, safer, and so on. So I'm kind of giving away the punchline, but let's just dive into this. So a little bit of background first, though. Data centers. This is an amazing statistic. Data centers in the United States account for approximately 2% of total U.S. electricity consumption. 2%. Now, that may not sound like a lot, but think about it. That's a lot.
Yeah.
And while data center cooling can account for up to 40% of data center energy use overall. So this is kind of the problem, right? Pat Gelsinger and everybody at Intel right now is going, wait a minute, that's unacceptable for a long-term future. And by the way, another thing about Hillsboro, Oregon, we are just this incredible, complex society of data centers. There's a bunch of data centers, right? I could walk to them from my house right now. So this is a real important story for me personally and all of my neighbors. Anyway, side note, how are data centers typically kept cool? Data centers use large amounts of water for their cooling system, which includes cooling towers, chillers, pumps, piping, heat exchangers, and condensers, and computer room air conditioner units, of course. And there's a source there in the data show notes that give you all the background if you want to dive deeper. In fact, the cooling systems in a data center can use as much electricity as the computers themselves. So it's a huge energy drain.
Right.
Now, to find a new way to dramatically cut the cost of cooling data centers, Intel is experimenting, so this is research, with submerging data center computers in a bath of synthetic oil that doesn't conduct electricity. Now, time out. This is not the world's first time liquid has been used for cooling, but this is the twist here, the synthetic oil. And we'll get into this here a little more. By not conducting electricity, the bath of synthetic oil does not cause the computers to short out. They thrive, in fact, because the fluid absorbs the heat from the computers much better than the air does. Now, a little historic note. This was really fun because this is where I add value to these articles, okay? This is my little contribution because normally I'm just picking up articles and just reflecting them back. But the historic note here is immersion cooling has been around since the 19th century, long before computers, when non-conductive fluids were used to cool early electrical transformers. And Ben, you know this. This is something you know. Supercomputers, starting way back in the 1960s, used immersion cooling as far back as the 1960s, but the technology remained, of course, highly specialized. Now, computers can operate in a variety of non-conductive fluids whose properties have various advantages and disadvantages for data center operations. So reality check, as I said before, we're not talking about, what we're not talking about is the world's first implementation of immersion cooling for data centers. Instead, the key to this news story, and this work by Intel, is the development by Intel of a safer immersion fluid alternative to current solutions in use today. And let me explain. For example, one category of immersion cooling today employs liquids that boil from heat, cool on a coil, and then rain back into a tank when they return to a liquid state. And frankly, this is a very efficient way to cool computers, but some of the fluids best suited for this purpose are so-called forever chemicals, also known as per- and polyfluorinated substances, the acronym PFAS, which unfortunately, ding, 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 have potentially harmful health effects and can persist in nature for many years. They don't degrade very quickly at all, right? So a little side note more about this, because I had to find out, wait a minute, what is this PFAS stuff? So per and polyfluorinated substances are a group of chemicals used to make fluoropolymer coatings and products that resist heat, oil, stains, grease, and water. Fluoropolymer coatings can be used in a variety of products, and I have a link here to the CDC website describing and explaining what these are all about. So these guys work great, but they're kind of not so great for the environment.
It's kind of like the stories you hear of like ancient Rome, and nowadays it's like, oh, they had lead water pipes. How innovative!
Yeah, right.
Nowadays you're like, that's really bad. So the more that we learn about these chemicals, the better.
That's true. That's true. My daughter and son-in-law's house, built in 1948 in Portland, Oregon, they had to have all the lead pipes.
You're right. You don't have to go back to ancient Rome for that. Yeah.
No. They had to have them all replaced, of course. Anyway, so back to the story in their Hillsboro, Oregon lab, Intel's engineers are using less hazardous liquids. These are petrochemicals made by companies like Exxon and Chevron with properties analogous to motor oil. Now, a little personal time out here for a second. This is very encouraging. It's a step forward. It's good. But unfortunately, we're still talking about something derived from fossil fuels. But maybe they can get a plant-based version someday. Who knows? We'll see. The clear fluid in question looks like water flowing gently through the tank that holds the servers, pumped up from underneath and then spilling over the top like an infinity pool for cooling before cycling back through the tank. And Ben, you're going to love this. With filtering, Intel says the chemicals it chooses can cool computers for 15 years without having to be replaced. 15 years. Okay. Well, a little concluding reality check here. Skeptics, caution that it may be difficult or prohibitively expensive to overhaul existing data centers to adapt to liquid cooling, but advocates of the shift, including Intel, say a transition is imperative to accommodate data centers' growing thirst for power and the growing development of more and more data centers. So, interesting development.
Yeah, it is interesting, and I was just trying to read an article real quick that Ralph, it's made with petrochemicals, but I'm also curious because just like you said, 15 years before you have to replace that, and I'm trying to think of while we know that drilling and mining and all that stuff is bad for the environment, don't get me wrong, most places we recycle car fluid or car oil. If we're not directly burning it, there are ways to recycle it, capture it, and make it not as bad for the environment. This being 15 years, maybe even find some way to then process it again and make it good for another 15 years. It's still a step in the right direction, like you said, and it's still not it's not as bad as other chemicals. All that aside, I gotta say, this is such a this is going to help it in a lot more ways. I know 40% for the cooling, Ralph, but also think that data centers, if you've ever seen engineers who kind of work in them, they have to wear, the covers over their, kind of like hair nets over their their heads. They have to wear boot covers over their boots so they don't track dirt in. They're almost, they're not as bad as NASA clean rooms when they're, designing stuff for space, but they're darn close because, normally they use big old fans that will draw air in, and if you can minimize the amount of dirt, you minimize the amount of cleaning, you minimize the amount of maintenance these things have. So by taking it liquid and immersion, you are taking out the need for potential cleaning hazards and smoke and other air debris that may get into these systems as well, because if it's a completely closed loop, that's just going to be better for everything. So this is a great win. And Ralph, I got to say that I don't think data centers are really going out of style anytime soon. If anything, we're going to need more and more and more of them as more of our lives go online. Yeah. So, hey, 40% of the entire electrical cost of these data centers is a huge win for the environment, no matter which way you cut it. So very uplifting story. And very cool because, hey, Ralph, data centers today, maybe one day we'll buy just these boxes that will have our computer submerged in these liquids as well, just so we get it at home. Maybe one day. Yeah. So,
and Ben, one last parting comment, sort of alluded to it a little bit at the beginning of the story. Folks, if you think Intel is just making the chips that are in, the brain chip, if you will, inside your laptop, think again. Intel has an immense research organization. When I joined Intel in 1993 and moved to Hillsboro, Oregon, I was so fortunate. I was the technology press representative for the Intel Architecture Labs, which is kind of, think of it like the MIT or the Bell Labs of Intel. And there's a litany of amazing technologies that Intel had very important influence on. One comes to mind, USB. I mean, there's so many things that we take for granted that you find out, oh, Intel was involved with this, or, oh, Intel co-collaborated this, or Intel invented this technology. So if you're interested, go out and learn more about the research part of Intel Corporation. It's a fascinating and very important historic story.
Yes, there's lots of another CPU, but there's also a lot of, they created, kind of the facial scan that we all enjoyed to unlock our computers, for instance, stuff like that. Intel definitely pioneered a lot of it. So with that being said, story number 2, very, very cool. And very, I guess cool now because it's not as warm. Story number 3 is going to go over to sculptures. And this is really cool. What was old is new again. And I don't know, just, hey, I guess we're mixing AI and I'm assuming 3D printing or something of the nature. But anyways, AI sculptures. What's happening here?
Yeah, this is fun. I got this from techexplore.com. There was no author associated with the story. But anyway, the headline here is Artificial Intelligence Sculpture based on the works of 5 art masters on display at Stockholm's National Museum. And, there's so much controversy about the Writers Guild in our country on strike, and part of their grievance or concern is AI taking the place in writing scripts and so forth. And there's so much concern in the art world, music world, you name it, right? About AI being this scary thing that's going to put people out of work and so forth. So you could add a little controversy to this story. On the other hand, it's just so fascinating, I thought, and I wanted to share it with everybody. And if you have the show notes or you're watching the video, you can see the sculpture we're talking about. So let's get into this story here. Images of the works of 5 master sculptors, including Michelangelo and Rodin and Takamura, have been used by Swedish machine engineering group, a company called Sandvik, Sandvik, to train an artificial intelligence system to design a sculpture they named the Impossible Sculpture, now on display at Stockholm's National Museum of Science and Technology. Now, the Impossible, it's called the Impossible Statue. Why? The impossible name for this statue relates to the fact that it represents a virtual collaboration or synthesis of the styles of 5 deceased master sculptors. And we'll get into that a little more in detail here. The stainless steel statue depicts an androgynous. Thank you. I stumble over that word. Person with the lower half of the body covered by a swath of material holding a bronze globe in one hand. And I don't know. I think it's more male looking to me than just kind of equal male female. But anyway, that's what they call it.
I definitely wouldn't call it androgynous. And let me pull up the picture here, right here.
Thank you.
But
that definitely looks more male to me. But,
and the proportions aren't exactly, I would say, really human either. Don't get me wrong. I've been going to the gym and I've been working out, but like to have a back like that, you would take an incredible workout, but still it's very, and Ralph, I guess like androgynous. I guess they're talking about the face, which you can vaguely see here in the picture.
Okay. Yeah, I can see that.
The face is definitely neither really male or female. And of course, the hair kind of goes down to the shoulders. Everything else, though, vaguely human, I guess, is why they say androgynous.
And again, if you're just listening to us in a podcast, come out to computeramerica.com, get the show notes, and you can see the picture and get the link and see what we're talking about. But anyway, The statue measures 150 centimeters, that's 4 feet 11 inches tall, and weighs 500 kilograms, which is 1,100 pounds. So this is a beast. And the idea behind this was, what if, it's a great what if scenario. What if we took the styles of 5 famous sculptors who made their mark on their era? Again, we mentioned Michelangelo, if you prefer, Auguste Rodin, Kathy Kolowitz, Kotaro Takamura, and Augusta Savage, a U.S. sculptor. So they all these folks are long gone, and sometimes not too terribly long gone, but nonetheless all deceased. And they said, what if we took their styles and synthesized them through artificial intelligence? And one note the author makes is that the muscular body inspired by Michelangelo and the hand holding the globe inspired by Takamura. So it's this synthesis. So Sandvik's engineers trained the artificial intelligence by feeding it a slew of images of sculptures created by the 5 artists in question. The software then proposed several images in 2D, which it believed reflected key aspects from each of the artists in question. As one of the Sandvik machine engineering group team members noted, in the end, we had 2D images of the sculpture in which we could see the different masters reflected. Then we put these 2D images into 3D modeling. Well, I went out to their website, deviated from the article in question, and started saying, how is this done? Tell me more about this Sandvik bunch and then how they did this. So the statue was fabricated by Sandvik, which is a global high-tech engineering group based in Stockholm, Sweden. And per the company's announcement, Sandvik's world-leading metal cutting tools, this is what they do, and expertise are used in a wide range of industries from aerospace to general engineering, automotive, and medical industry. The impossible statue was made possible through an innovative use of AI modeling and the latest cutting-edge manufacturing solutions. It's crafted from stainless steel, and the complexity and precision required to make the statue a reality put Sandvik's advanced digital manufacturing solutions and cutting tools to the test. This is what they wanted to do. They wanted to show the world this extreme example of what their technology and solutions could do. And for more on how it's made, I've got a link in the show notes. You can really get into that. A combination of different AI programs resulted in a 3D mesh model. The mesh consisted of 9 million polygons. Wow. The mesh model was then converted into a solid model that the team's computer-aided design and computer-aided manufacturing programs could work with. After this conversion was achieved, the team started programming the CNC machines using Mastercam software. Okay, wait a minute, time out. CNC stands for Computer Numerical Control, and these machines play an important role in the manufacturing industry these days. As one of the developers from Sandvik noted, originally we planned to make it in one piece, but we realized the size made it impossible. We had to adapt the parts to fit our CNC machines, so we sectioned the model into 17 components. Each of these had to be designed and programmed along with interfaces between them. This is a triumph of computer-aided manufacturing and CNC and all the rest of it. It's a pretty great story on many levels. But again, their motivation was to show the world how sophisticated their technology is.
And it's a great, kind of mix. And to throw AI, not just to throw AI because they can, but Ralph, I like, this is a very, I guess, kind of like harmless way to use AI. Like, it's no one who's lived really, a couple people died, about 80, 90 years ago. But to resurrect their style using artificial intelligence and then come up with a statue that, they're able to then print. I mean, it's very cool. I don't see sculptors going out of business anytime soon, or artists who, kind of would draw these things. But if they needed something to really highlight how good their tools are, this was a very innovative use of AI to, highlight that. So I guess, Ralph, like when we talk about AI stories, it's like, well, that's kind of sketchy, but not this one. This is a good use of AI and definitely a very cool use of their technology.
Yeah, and Ben, I'll pick up on that a little bit too. I thought to myself, I guess you could say the ethics of this. Again, think about the Writers Guild's concern. Think about musicians' concerns. If they had if they had a sculpture and just said, we're going to look at Michelangelo, and we're just going to show the AI a whole bunch of Michelangelo sculptures and make a fake Michelangelo or a pseudo Michelangelo statue that's going to fool everybody. Experts would look at it and say, where did you find this Michelangelo? That could be kind of sketchy on the ethical edge. But again, what they did here, I thought was fun and okay, if you want to say that, is saying, let's take 5 deceased master sculptors. Let's show the AI images of all of their works and have fun and see what. So nobody's trying to tell you this is a Michelangelo sculpture or a Rodin sculpture. It's more the synthesis. And I think this is where AI can be really cool and fun in the world of the arts and not be a violation of somebody's will be legitimate works or whatever. But you get my picture.
They're not putting, everything Michelangelo ever created into one machine and saying, make me a new Michelangelo. No, they're blending a little bit of everything, which, that's what humans do. That's what people do. And that's where the creativity kind of comes from. Again, no one's losing their job over this one, but the finished statue looks amazing. So definitely go check that out. Fun. Yep. So story number 4, Ralph, let's go ahead and skip on down to, as is your tradition, a little bit of medical technology. So story number 4.
Yes. This is great. Ben, we like to end each Friday segment, technology trends and science trends and so forth, with usually, not always, but something from the world of medicine. And this touches all of our lives. And this story certainly touched my life. I very recently had an ultrasound for just a routine. Thank goodness it wasn't scary. But the headline here is new wearable. Wait a minute. New wearable ultrasound system can monitor deep tissues. Folks, if you need a refresh ultrasound, the classic thing, the woman is lying on the table, she's pregnant, and they put the gel on her tummy and they take the little wand and they go, that's ultrasound. Okay. So immediately you know what we're talking about. But you know that's a big piece of equipment, right? And in the doctor's office or in the hospital or in the ER, we're talking about a wearable ultrasound system that's been developed that can monitor deep tissues. Got this from medgadget.com, which if you're into medical technology, this is a wonderful website. Story by Conn, Hastings, and Ben. You and I have done stories from him many, many times over the last few years. Again, come out to computeramerica.com, get the show notes. We've got the link. And there's also a link to the research team's paper they published, which was titled A Fully Integrated Wearable Ultrasound System to Monitor Deep Tissues in Moving Subjects. Not only this thing wearable, but the moving subjects. We'll get into this. The show notes have some great images. Of course, they had this groovy male model showing off this thing. I think I would have just used a more regular, normal person. But anyway, it shows what this thing is like and shows its flexibility and so forth. Well, let's get a little background. Ultrasound imaging or sonography uses high-frequency sound waves to view inside the body. Because ultrasound images are captured in real time, they can also show movement of the body's internal organs, as well as blood flowing through blood vessels. And I've got the FDA government site source there for that if you want to learn more. Now, here's the story. Researchers at the University of California, San Diego have created a wearable ultrasound system that can monitor deep tissues as far as 16.5 centimeters or 6.5 inches deep in the body. Wow. Below the surface of the body, and the device is flexible, allowing good skin contact and comfort for the user during use. And the team employed a machine learning algorithm, ding, 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 AI, there you go. The team employed a machine learning algorithm to reduce the noise associated with movement. So it's, usually when you have an ultrasound, like my recent ultrasound, or every woman listening to this who's been pregnant and had an ultrasound, you're supposed to lie still while they move the wand over you and so on and so forth. And my ultrasound was the same way. So the team employed a machine learning algorithm to reduce the noise associated with movement, helping to obtain reliable readings while the user goes about their day. So we're talking about an opportunity to periodically or continuously monitor while you're wearing this thing and living your life.
Because
we'll get into why that's...
Yeah, I'm not the most familiar with how exactly it works, but I'm guessing it's kind of like a CAT scan, something like that, where it takes like little slices of an image, and then you put all those images together to get more of a 3D picture than you would if you just kind of use that. I'm assuming, or maybe it's more like a big blank. I really don't know. I apologize. So
yeah, if you think about it, it's the sound bouncing constantly off of the matter inside your body, right? And it's bouncing back, and you're just getting like a movie, a continuous movie. Think of it sort of kind of like a colonoscopy or endoscopic thing where you have a camera that goes down the throat.
I got you.
The behind, okay. But it's like a movie, okay.
So that's where the movement would really hinder it, because it'd be like kind of watching like a shaky cell phone video. It's not at all. But then of course you see like the stabilizing cell phone video. It's much better. That makes sense. Thank you.
Kind of sort of analogous to the stabilization technology that developed for video cameras, which transformed the cinema world and elsewhere, right? So this, so again, it can work with movement. Obtaining reliable readings while the user goes about their normal life. The sensor can evaluate cardiovascular function in motion. That's the key. This is important as abnormal values of blood pressure and cardiac output at rest or during exercise are hallmarks of heart failure. So time out. As a cardiac patient myself, I totally get this. It's one thing to lie down still in the doctor's office or the ER or the hospital and have a reading of your heart, blood pressure, and so forth. It's another thing to what's going on when I'm moving around, when I'm walking or exercising or just even sitting here talking to you. Medical diagnostics would like to have the total picture. And that's what this wearable ultrasound device gives them the opportunity to have, something they haven't really had before. Wearable ultrasound that can give me a total picture of what's going on with Ralph's heart or your heart or whatever the case may be. So the deep tissue functionality and 12-hour battery life mean that the wearable is suitable to monitor a variety of physiological parameters, including cardiac output, blood pressure, and heart rate. And for healthy populations, people who are chronic health issue people, but just everybody, the new University of California, San Diego device can measure cardiovascular responses to exercise in real time and thus provide insights into the actual workout intensity exerted by each individual person, which can guide the formation of personalized training plans. This is profoundly important potentially for physical therapy and other things of this nature, right? Or even for physical activity nuts, real enthusiasts who someday might have a smartphone app that's talking to this thing that's on their chest and showing them, really interesting information about what's going on with their heart, for example, during exercise.
I'm sure that if you did suffer some kind of cardiac issue, and if you're an athlete, the person wants to get back to it as fast as they can. Doctors are saying probably don't do any exercise for a year plus and let your body heal.
Interesting.
And finding kind of a middle ground, Ralph, of how much is too much, and then kind of backing away from that line, but still getting the exercise that the body needs. Very important.
Yeah, I can't stress enough how profound this story is in its possibilities for monitoring real time with no restrictions. It's just, gotta love it. Anyway, fun to kind of wrap this up. A little fun fact about this story. The author put forth, the researchers had originally intended to design a blood pressure monitor. That's it, blood pressure. Okay, but they realized the technology may have greater functionality, and it sure does, including monitoring cardiac output, arterial stiffness. This is something that we kind of don't think about a lot, but that's a biggie. Volume of exhalation of air from the lungs, and more, all of which are essential parameters for daily healthcare or in hospital monitoring. Wow. I love it. It's such a great upbeat way to end today's show.
I'm so curious, and clearly this thing could do blood pressure as well as other monitoring. Ralph,
Sure.
You can see the technology there. In the article, you can see the pictures.
Right.
It's I would say not that much bigger than the first thing that comes to my mind is like a Game Boy cartridge, but what would be a better about half the size of like a cell phone, on this person's chest. And Ralph, I'm kind of curious, like, Apple has been making a lot of inroads with the Apple Watch into continuous monitoring of patients, so that when you go to your doctor has, a 30-day, 60-day kind of health record of you, not just like you said, when you're in the doctor and they do measurements and that kind of thing. Instead of spot checking, they have like a full overview. Ralph, I'm curious if whatever technology is in here may one day make it into either our cell phones, kind of have the cell phone and, be able to kind of take this or your smartwatch. And Ralph, imagine if you could take your smartwatch off your wrist and kind of hold it up to your chest and, kind of check for, either arrhythmia or blood pressure or maybe even, any of these issues that this article already talked about. I'm wondering if this can be cheaply and safely integrated into a fitness watch, or even not every fitness watch, maybe very specialized for, outpatients, smart watches that could then double as that technology at home. A lot of fun ideas.
Oh, yeah, absolutely. Or I think probably more likely for the near term, if this goes on in further development, would be a little patch that you would comfortably, and that's what they keep emphasizing, this is comfortable, flexible, and so forth, that you do wear on your chest. And but to your point, it's communicating with your smartwatch or communicating with your smartphone.
True.
And then what I just to personalize this for a moment, not recently, I finished 2 weeks, my cardiologist, and I have a blood pressure machine at home, taking twice a day, different times of the day, blood pressure readings and so forth. And then I had to document it in a little Word document and so forth. And then I sent it to him after 2 weeks. Wouldn't it be neat if I had this device, this flexible thing on my chest? It's linked to my smartphone. It's documenting everything continuously. And my cardiologist could pop in at any time and kind of get a graph of showing, what's going on with Ralph's heart over this period of time, or at any time. Or I could provide the cardiologist with an output report, all online, all on the cloud. I mean, that sort of thing, just again, because I've been a heart patient for so many years, the implications of this technology for that field are absolutely incredible. Wonderful stuff.
and even with that aside, that's the next level of healthcare is, Ralph, you start managing by exception, which means that if, let's say, Ralph's readings are out of line or they're trending upward, then the doctor wouldn't even have to notice it. The computer would go, "Hey, doctor, check out Ralph. He's, things are getting a little wonky," and you'd get care immediately, faster and better. And ladies and gentlemen, everyone is going to benefit from little innovations like this over time. So, Ralph, I want to thank you for turning us on to this story and all the others. If you want any of them, computeramerica.com, Ralph's website, and of course, our tab over at computeramerica.com will have all of Ralph's segments. Until next time, have a great day. Thank you so much. Catch you next time. Bye, everyone.